Hi friends, welcome to all. In this video, we are going to configure CCNA ENCOR packet tracer, IPv4 and IPv6 static and default routes. Friends, please consider subscribe, share and like our channel. And also, if you wish to get any technical support, you can contact our team. All the details given in the description below. Here we can see the topology. Edge router connected to ISP1 and ISP2. So we have a redundant ISP connections. And also we can see here LAN 1 and LAN 2. All the devices are configured with IPv4 and IPv6. So we are going to configure here IPv4 and IPv6 static and default routes. Here they given the addressing table, all the device, its interface and IPv4, IPv6 addresses here. So in this packet tracer summary activity, we will configure static default and floating static routes for both the IPv4 and IPv6 protocols. Configure IPv4 static and floating static default routes. Then configure IPv6 static and floating static default routes. Then configure IPv4 static and floating static routes to internal LANs, that is for LAN 1 and LAN 2. Then configure IPv6 static and floating static routes to the internal LANs. So they configured both IPv4 and IPv6. Then configure IPv4 host routes for this customer server. Then configure IPv6 host routes. In this activity, we will configure IPv4 and IPv6 default static and floating static routes. The static routing approach that is used in this lab is used to assess your ability to configure different types of static routes only. This approach may not reflect networking best practices. Okay, so this is for only checking our ability, how we can configure this different static routes. In part 1, we will configure IPv4 static and floating static default routes. The PT network, that is packet tracer network, requires static routes to provide internet access to the internal LAN users through the ISPs, ISP1 and ISP2. So in addition, the ISP routers require static routes to reach the internal LANs. In this part of the activity, we will configure an IPv4 static default route and a floating default route to add redundancy to the network. Okay, so configure an IPv4 static default route. So this is what we are going to do first. On edge router, so here is our edge router. Configure a directly connected IPv4 default static route. Directly connected. Okay, this primary default route should be through router ISP. So it should go through ISP1. Right. If it is through ISP1 and we should use a directly connected default route. So this will be the exit interface, that is serial 0/0/0. So we can configure now it on edge router. Enable configure terminal IP route. Here is the default route. Then exit interface is serial 0/0/0. Now configure an IPv4 floating static default route, because we got here ISP2 also. On edge router, configure a directly connected IPv4 floating static default route. This default route should be through router ISP2. Okay, it should have an administrative distance of 5. So we must specify AD because we are configuring default, a floating, static default route, as we have redundancy here, redundant route here. So we will do that. And here, if you want to go through ISP2, the exit interface, it is serial 0/0/1. Okay, we can do that. IP route. Then exit interface is serial 0/0/1, and also we must specify the AD5. We will verify this default route we configured on edge router. Exit show IP route. So here we can see one entry, the default route we configured directly connected through serial 0/0/0, and that backup route we configured serial 0/0/1. So we cannot see that entry here in this routing table. There is a backup route. So we can see that in our running configuration. Show running config. So here we can see we configured that backup route also. This route will be activated only when our primary route goes down. Now in part 2, configure IPv6 static and floating static default routes. In this part, we will configure IPv6 static default and floating static default routes for IPv6. This is the same router, edge router. So step 1, configure an IPv6 static default route. On edge router, configure a next hop static default route. So next hop static default route. This primary default route should be through router ISP1. So here, as we need to use next hop, we should get the IP address of this interface serial 0/0/0 on ISP1. So it is there already in our addressing table. ISP1 serial 0/0/0 IPv6 address. Just I will copy that. Now we'll go to edge router, configure terminal, IPv6 route. Default route here is /0. Then next hop address through ISP1. Then we can see configure an IPv6 floating static default route. So through ISP2. On edge router, configure a next hop IPv6 floating static default route. The route should be via router ISP2. Yes. So use an administrative distance of 5. Here we should get the IPv6 address of this interface serial 0/0/1 on ISP2. So we'll go to our addressing table and we will get that ISP2 serial 0/0/1 IPv6 address is here. Just I will copy that. Then we will configure this floating static default route. IPv6 route /0. We already copied our next hop IPv6 address. Then AD, that is 5. Okay, so we configured part 2 also, configure IPv6 static and floating static default routes. So we can verify that on this edge router and show IPv6 route. So here we can see that default static route we configured via ISP1, and we configured backup route also via ISP2, which is not listed here in this routing table. It's a backup route. Show running config. So here we can see this is the primary route and this is the backup route to be configured through ISP2. Next, we will go to part 3. Configure IPv4 static and floating static routes to the internal LANs. So here we can see those two LANs, LAN 1 and LAN 2. So in this part of the lab, we will configure static and floating static routes from the ISP routers to the internal LANs. Okay. So step 1, configure IPv4 static routes to the internal LANs on ISP1. Okay, we are going to configure on ISP1. Configure a next hop IPv4 static route to the LAN 1 network through edge router. So here we must configure a next hop IPv4 static route. Here we should get the IPv4 address of this interface serial 0/0/0 on edge router, as we are going to configure using next hop. So we can go to our addressing table. Edge router, here we can see serial 0/0/0 IPv4 address. So just I will copy that. And here we can see our LAN 1 IP address 192.168.10.16/24. We are going to configure this static route on ISP1. Enable configure terminal. IP route network address is 192.168.10.16. Okay, /28. That means subnet to mask is 255.255.255.240. Then our next hop address already we copied the IP address of this interface serial 0/0/0 on edge router. So just I will paste it. 10.10.10.2. Part 3. Next is on ISP1, configure a next hop IPv4 static route to the LAN 2. Here we can see LAN 2 network through edge router. Okay, here only we need to change the network address. It should go through edge router. So we can do that on ISP1. IP route. Here we can see LAN 2 IPv4 address 192.168.11.32. 192.168.11.32. Then prefix they given as /27. So subnet to mask is 255.255.255.224. Then the next hop address already we have done previously here 10.10.10.2. 10.10.10.2. Next in step 2, configure IPv4 floating static routes to the internal LANs, because we can go to these LANs, that is LAN 1 and LAN 2 from ISP1 through ISP2 also. Previously we configured directly from ISP1 to edge router, then to the LAN 1 or to the LAN 2. Now we are going to configure the floating static routes from ISP1 through ISP2 and edge router, then LAN 1 or LAN 2. Because whenever this primary route goes down from ISP1 to edge router, we can communicate through ISP1, ISP2, then edge router and these LAN networks. On ISP1, configure a directly connected floating static route to LAN 1 through the ISP2 router. So it's directly connected. Okay. Use an administrative distance of 5. Here we need to configure directly connected floating static route. So we can see the exit interface here on ISP1. This is G0/0. So now we can configure it very easily. Okay. So this is our first route, LAN 1. So IP route 192.168.10.16, then subnet to mask. Then we should give the exit interface G0/0, then AD, administrative distance 5. Again on ISP1, configure a directly connected floating static route to LAN 2 through the ISP2 router. Use an administrative distance of 5. Okay, so here we already configured static route. IP route. So here we can see LAN 2, that is 192.168.11.32. 192.168.11.32, then submit mask. Exit interface is towards ISP2, so G0/0, then AD is 5. We can verify the routing table on ISP1. Show IP route. So here we can see those two static route we configured via our edge router via 10.10.10.2 for those two LANs, LAN 1 and LAN 2. And that backup route is not listed in the routing table. So it will be listed only when this path or this from ISP1 to edge router goes down. Show running config. So here we can see those four static routes we configured. These are the primary route for LAN 1 and LAN 2, and these are the backup routes for LAN 1 and LAN 2. Now we can move to part 4. Configure IPv6 static and floating static routes to the internal LANs. Same like IPv4. Now we are moving to IPv6 from ISP1 to LAN 1 IPv6 and LAN 2 IPv6. So configure IPv6 static routes to the internal LANs. On ISP1, configure a next hop IPv6 static route to the LAN 1 network edge through edge router. In the same way, on ISP1, configure a next hop IPv6 static route to the LAN 2. So here they given the IPv6 address, network through edge router. So we will configure these two on this router ISP1 through edge router. So here as they specified to use a next hop IPv6, let me copy the IPv6 address of this interface serial 0/0/0 on edge router. So on edge router serial 0/ here we can see the IPv6 address. Let me copy that. Coming to ISP1, just I will keep it here so that we can get the IPv6 address of LAN 1. Configure terminal IPv6 route. And here we can see 2001 db8 1 10 /64. Then we are going to give a next hop IPv6 address. Okay. Perfect. Now we are going to give for the LAN 2 on ISP1. Same, but only this network changes here because we are going to give LAN 2. That is 2001 db8 1 11 /64. So IPv6 route. So here I can copy this address. Okay. Then next hop IPv6 address, that also I can copy from the previous command. Then press enter. So we completed part 4, step 1. Next is configure IPv6 floating static routes to the internal LANs. So that means when it goes down this path, we can go through ISP2 also. So we are going to configure this backup static route through ISP2. So here also we are going to use next hop IPv6 address. So we should get the IP address of this interface G0/0 on ISP2. On ISP1, configure a next hop IPv6 floating static route to the LAN 1 through the ISP router using an AD of 5. Also on ISP1, configure a next hop IPv6 floating static route to LAN 2 through this ISP2, and here also we should use our administrative distance of 5. So we can get the IPv6 address of G0/0 on ISP2. So just I will copy that. Now coming back to ISP1. IPv6 route. So this is our LAN 1 IPv6 address 2001 colon DB8 colon 1 colon 10 double colon slash 64. I already copied next hop IPv6 address. Okay. Then AD, administrative distance 5. Then this LAN 2 IPv6 address. Then our next hop address with AD. Okay, perfect. So both we configured. Both backup route we configured through ISP2. We can verify this. Exit show IPv6 route. Here we can see two static routes in the our routing table. We configured 4, but we can see only 2 because 2 are backup route. We can see that in our running config. Here we can see that our IPv6 route, static route. If your configuration has been completed correctly, you should be able to ping the customer server from the host on LAN 1 and LAN 2. In addition, if the primary route link is down, connectivity between the LAN host and the web server should still exist. So here now we will be able to ping from PC-A and PC-B to this customer server using either IPv4 or IPv6. Even this link goes down, these two LANs will be able to communicate to the customer server. Okay, we will try that. Let me get the IP address, IPv4 address of customer server, and we will ping from PC-A first. So we are waiting for the replies. Yeah, we get the replies. Now I will ping from PC-B also from LAN 2. We get the replies. Okay, we will try to ping to the IPv6 address. Okay, we get the replies. Same, I will ping from the other LAN PC-B and we get the replies. Now we will disconnect this network. I mean the link between edge router and ISP1, and we will test the connectivity. We are going to remove this connection and we will test the connectivity. It should succeed because we already configured the backup route through ISP2. So we will again ping to the customer server from PC-A, PC-B using IPv4 and IPv6. So first of all, I will try using IPv4. Okay, we may get 1 or 2 requests timed out. We are waiting for the replies. Yes, it is working. Same way we will check for IPv6. It is working. Perfect. Now we will go to PC-B using IPv4. The backup route become active and added in the routing table, and be able to communicate to the customer server, including IPv6. I will try with IPv6 also. Yes, it is working. Let me connect back edge router and ISP1. Serial 0002, serial 000. Okay. Now we will go to part 5, configure host routes. Users on the corporate network frequently access a server that is owned by an important customer. In this part of the activity, we will configure static host routes to the server. One route will be a floating static route to support the redundant ISP connections. In step 1, configure IPv4 host routes. So first we will configure IPv4 host route. On edge router, configure an IPv4 directly connected host route to the customer server, and also a directly connected floating host route to the customer server with the administrative distance of 5. We will do that. Let me get the IPv4 address of customer server already given here, or we can get it from the addressing table. So we'll go to edge router, and they specified using directly connected. So it is too easy to configure. Enable configure terminal IP route, then the IP address, not the network address, the IP address of our customer server. Then we need to give the mask all 255. Then exit interface, that is serial 0/0/0. Okay. Now we are going to configure the backup static route, that is floating static route. So here we will give IP route, the IP address of our customer server, then 255.255.255.255. Then our exit interface is through ISP2. So I need to give a serial 0/0/1 with administrative distance 5. Also, we need to configure IPv6 host routes using its customer server IPv6 address. On edge router, configure an IPv6 next hop host route to the customer server through the ISP1 router first, then using the ISP2 as the floating host route. And here also we should use our administrative distance of 5. So we can do that, or just I will get the IPv6 address of this customer server. Then we'll go to edge router. So it's configure an IPv next hop host route. Here I should get the IPv6 address of this interface serial 0/0/0 on ISP1. Okay. So just let me give IPv6 route. Okay, just first I will copy this address, customer server IPv6 address /128. Then we should get the next hop IPv6 address ISP1 serial 0/0/0. Okay, let me copy this and paste. Okay. And finally, floating host route to the customer server, they specified using IPv6 directly connected. Okay, let me try that. So exit interface is here serial 0/0/1 through ISP2. So it's the same serial 0/0/1 administrative AD administrative distance 5. Okay. But I think it's not going to work. We can see the percentage is still 93%. So we are going to configure using next hop address only. So let me remove this. No. And we will remove this line. And we are going to configure. We are going to remove this exit interface, and we should get the next hop IPv6 address of this ISP2. ISP2 serial 0/0/1. Let me copy that and paste here with the administrative distance 5. Okay. Perfect. Now we can see our score. Completion status 100%. So there is a small change here. It is not IPv6 directly connected. It is IPv6 and next hop, floating host route. Okay. So that's all in this lab activity, that is configuring IPv4 and IPv6 static and default route. Friends, if you get any doubt regarding this activity, you can contact us. All the details given in the description below. Stay tuned. We will meet again with the next video. Thank you.